We are covering two different sections today, section 1.5 as well as 1.6. Both have a bunch of definitions in there. You do have a guided notes handout that has a lot of the definitions on them, either in matching form or just I straight up gave you the definition, one of the two. 1.5 is titled Angle Pair Relationships. Relationships between pairs of angles. First thing we're talking about is the difference between complementary and supplementary angles. Complementary angles are simply two angles that add up to 90 degrees. Two angles, when added together, add up to a right angle. So something like that. If this is a right angle, then angle ABC and angle CBD are said to be complementary. Supplementary means the same thing, but now they add up to 180. If we add up to 180 degrees, this obtuse angle and this acute angle are supplementary because they line up in a straight line when I set them next to each other. Any two angles that add up to 180 are called supplementary angles. If they add up to 90 degrees, we call them complementary angles. A linear pair, adjacent angles and vertical angles. Let's start with adjacent angles. Adjacent angles are two angles that share a side. Two angles that share a side are called adjacent angles. I'm going to call this angle 1, this one angle 2, this one angle 3, and this one angle 4. Angles 3 and 4 are adjacent because they share this side right here. Vertical angles are two angles that are across from one another. On intersecting lines. So if we have two intersecting lines, which we do here, the ones that are across from each other, angles 1 and 3 are said to be vertical. Angles 2 and 4 are vertical. And a linear pair is two adjacent angles. So they need to share a side that are supplementary. They add up to 180. Which, if we're calling them a linear pair, a line, it makes sense they match up in a straight line. So angles 1 and 2, we could call them supplementary because they add up to 180. We could also call them adjacent angles because they share a side. And because they're both supplementary and adjacent angles, they also form a linear pair. So if I have a couple angles like this, and suppose this one's 130, and then I've got another one here, this one's 50 degrees. We say these are supplementary angles because they add up to 180, but we don't call them a linear pair because they're not adjacent to one another. Now we could redraw it so that they are adjacent, and now they would be a linear pair. But as they're drawn, they're just supplementary angles. angle 1 and 2 here. Angles 1 and 2, those are adjacent angles because they share this side. But they don't add up to 90, and they don't add up to 180, so they're neither complementary nor supplementary. So those are just adjacent angles. Example 1 is a relatively easy one. It says, given that angle 1 is a complement of angle 2, we are looking for the measure of angle 2 if we know that angle 1 measures 17 degrees. So we know angle 1 is 17, and complementary means I add it to angle 2, and I get 90 degrees. So x, which is the measure of angle 2, would be, what, 73 degrees? And that's really just testing your understanding of what complementary means. Example 2 says two roads intersect to form supplementary angles. Those supplementary angles are X, Y, W, so this one here, and W, Y, Z, this one here, which they sure looked supplementary. We're looking for the measure of angle X, Y, W. So we want to know what this angle right here is. We know for sure that these two angles are supplementary. They form a linear pair. If I add them together, 2x plus 14 and 4x minus 20, we know they add up to 180 degrees. Two x and 4x, that makes 6x. 14 minus 20 is minus 6. Add 6 to both sides. Divide by 6. What is that, 31? And make sure we answer the question. 2 times 31. 76 degrees. And we can check that. If I plug 31 in over here, I get 124 minus 20, which is 104. And notice they do add up to 180, which is good. That's what we're looking for. 76 degrees, angle XYW, XYW, which was that? Example 3 gives us a figure, and it asks us to identify a set of vertical angles, a linear pair, and a set of adjacent angles. Vertical angles, a linear pair, and adjacent angles. I'm going to start down here with C. Adjacent angles, there's a bunch of them. Angle 1 and angle 5, they share this common ray. Angle 1 and angle 5 are adjacent. 5 and 4 would be adjacent. 4 and 3 are adjacent. 3 and 2 are adjacent. 2 and 1 are adjacent. Any set of angles that have a common ray, one of their sides line up, are called adjacent. Easy enough. Part B wants a linear pair. A linear pair means that they're adjacent, so they share a ray, and they line up in a straight line. They form a straight line. They are supplementary. Angles 1 and 2 would be a good example of that. There's one more set. 2 and 3 are also a linear pair. And vertical angles mean if I have two intersecting lines, They are right across from each other. In this case, I've got these two intersecting lines. The only vertical angles we have are 1 and 3. 2 is vertical to the sum of 4 and 5, that angle right there, but it's not vertical to any one specific angle. If we had like points, I suppose we could name it B, A, C or something like that. Angles 1 and 3 are the only ones that are defined and are vertical. That was 1.5. 1.6 is titled Polygons. A polygon is defined as a closed plane figure with at least 3 line segments, which we're going to call sides, where each side intersects exactly 2 other sides only at its endpoints. Sheesh. First of all, it has to be closed. So it can't look like this. That is not a polygon. It's not closed. It's got this open area right here. I can sneak on in there. That would not be a polygon. It needs to be at least 3 line segments. Also not a polygon here. Not a polygon because it's not closed and it only has 2 line segments. Also, each side intersects exactly 2 other sides only at its endpoints. So it can't look something like this. Because notice it intersects here also. We can't have any of the sides that cross one another. Something like this is a polygon. As long as that's straight. They all do have to be straight lines as well. So even if I close this, not a polygon because that's not a line segment. They all need to be line segments. We have a couple different types of polygons. We have convex ones and concave ones. Convex means all the interior angles are less than 180 degrees, which remember 180 degrees is straight across. So interior, all the inside angles are less than 180 degrees. Something like this. All of my inside angles, none of them are more than 180, more than a straight line. They can be obtuse. That one's obtuse here. That's more than 90. But they can't be more than 180. Something like this. All of my interior angles, so that one's less than 180. That one's less than 180. That one's less than 180. But this one, notice, is more than a straight line all the way around. These are all okay. But this angle, this interior angle here is more than 180 degrees. That is called concave. Easy way to remember it, a cave goes inward. Notice this one here has an area that goes inward. Looking back at this one, notice this is a concave polygon. We have lots of different names for polygons. Polygon of 3 sides, you're pretty familiar with, I hope. That's a triangle. You should be familiar with most of these. 4 sides, it might be a square, it might be a rectangle, but those are special types of quadrilaterals. 5 sides is called a pentagon. 6 is a hexagon. 7 is a heptagon. We've got an octagon. 9 sides. 9 is called a nonagon. 10 is a decagon. And 12 is a dodecagon. So most of these you should be pretty familiar with. Maybe 7, heptagon, you're not super familiar with, or 9. But most of those you've heard before. N, so anything that's not listed here, like maybe we have a polygon that has 15 sides, we just call it a 15agon or a 22agon, an n-agon, whatever n happens to be. Last couple definitions here. Equilateral, an equilateral triangle means all sides are the same. All sides are congruent. Equiangular, all angles are congruent. And a regular polygon means that it has to be convex and it has to be equilateral and equiangular. So all sides need to be congruent, and mine's not going to be perfect. So all these sides are the same. All the angles are the same as each other. They're all congruent. And it has to be convex. We don't have any of those little cave areas you can get into. That's a wrap for the notes. Reach out if you have questions.